Hello again, everybody. Another schematic, but this is a little more simpler than in recent past videos. Simple circuit. This is just two horns actually in parallel across each other. That hint number one means that they get the same voltage as soon as you see these two on parallel. 12 volts here, then 12 volts here. Where do you start in a schematic? You have a horn problem. Neither horns, you have two horns, neither horns are working. Or, instead of horns, we can put two lights are not working. This could be your parking lights or your hazard lights, doesn't matter. These two components are not working. First of all, we have to analyze how the circuit works before we know how to troubleshoot. The starting point, as I always focus on, where's the starting point? Main components. A relay is a main component. Obviously, the horns are a main component. Or if these would be lights, light bulbs, filaments, and the switch. What do we need first to happen? We always need 12 volts on one side of a relay. And we need a ground on the other side. Like we said, the ground could be through a switch, like in this case, or a physical ground, or it could be a computer giving you a ground. In any of those cases, we don't have a computer here. What we do have is a horn switch that you activate when you press the horn switch on your steering wheel. That will give us the ground. So that's number one. Make this, create a magnetic field, energize this coil. When you press this, I'm completing the path for current to flow. Current can flow from the fuse, from the battery, from the one side of the fuse coming out the other side. Current flows here at pin 1, comes out the other side through this green and black wire, or blue wire, probably black, and then this again to this switch to ground. So we have a complete path. Once this is activated, number 2 happens. This contact is now closed. So current can now flow this way, this way, this way, and divide this way. Let's take into account voltage drops. We just said we have a problem. The horns don't work. Both horns don't work. Okay? We always pay attention if one horn works, or the other one doesn't work, or one light bulb doesn't go on, or both lights go on. Do your front lights go on? Do your back lights go on? That's a hint to troubleshooting. Always pay attention to other things that do work, not just what doesn't work. So in this case, if we only have one horn not working and this working, obviously the relay is good and the fuse is good. So we know it's this. But it's got a little complicated by the fact that both of them don't work. Now, is the switch at fault? Is the relay at fault? Is the fuse at fault? Let's go over voltage drops. Now, we know a good fuse has to have 0 volts across it. Why? Because it has low resistance. So if I measure 12 volts here, and I measure 12 volts across here, right away I know the fuse is intact. I come down here and I say, okay, where am I going to measure? Am I going to go to the connector of the horns? And I measure 0 volts. 0 volts over here. That tells me either I'm shorted to ground. It could be that this wire is going to ground. The green and white wire is going to ground. Possible. If that would blow the fuse right away, among other things. But the fuse is good. So it can't be a short. Must be an open. What's open? Let's see if this is activated. If this is activated, if this switch is good, I should have 12 volts here, 0 volts here. Again, it's hard to find going to a relay. When the relay is inserted inside the fuse box, making the connections, it's hard to go under the pins unless you have a relay inserter or a relay test a box. So therefore, try to find a place on the same wire where you can test it voltage wise. Now, this over here is like a jumper from here to here. I can take this out and measure the voltage across here. So when you do this, when you jump, you need, when the jumper wire is here, it connects it to ground. If you take out the jumper wire, this will be 12 volts. This will be 0 volts. So what am I saying? I have to get, if this is working 12 volts over here, we just said that, 0 volts over here. If I measure 0 volts here at this point, the other side of the junction, that tells me this is good. This is connected to ground. Right? If I measure 0 volts over here, that means this must be open. So this is a critical point to measure, if you can get access to that point. Remember, the problem is both horns are not working. We first assume in a relay this has to be activated. How do we know this is activated? We know by the fact that this is 12 volts over here on pin 1, and this should be, pin 2 should be 0 volts. Why? Because this is connected to ground, a straight wire to ground. If there is no ground, or this is open, let's say the switch is defective, what will we measure? We will measure 12 volts over here. 12 volts here, 12 volts over here. That tells me there is no voltage drop across this. This is not conducting. This might be defective, or this might be open. So again, if this is open, let's say there's a defect in the switch, I'm not going to measure 0 volts. I'm going to measure 12 volts here and 12 volts over here. Again, if I measure 12 volts over here and I measure 0 volts over here, this is good. The problem might be this. So, in summary and in conclusion, you first have to find out the voltage drops. Where's a good point to start? Of course, at the fuse. In this one, I will start with the fuse and make sure I have 12 volts going through the fuse. Once I do that, I have to verify that the switch is good, the one that you press on the steering wheel. The way I activate that, or I prove that, is by 0 volts at this pin, if you can get access to that. That's the whole trick of it. If this is 0 volts, this is 12 volts, I have 12 volts across the coil, it is activated, it is good. If this opened up, if it's not making contact, 12 volts here, 12 volts here. This will not be activated. So again, I would rely on the switch, I would rely on the relay most of the time. Anyway, thanks for watching. Please subscribe to my channel, Automotive Electronic Schematics by Joseph, and the other one is Joe Electronic Schematics for Auto. Thanks for watching.